study about International System of Units. In earlier times, scientists of different countries were using different systems of units for measurement. Three such systems, the CGS, the FPS or British system, and the MKS system, were in use extensively till recently. The base units for length, mass, and time in these systems were as follows. In CGS system, they were centimeter, gram, and second respectively. In FPS system, they were foot, pound, and second respectively. In MKS system, they were meter, kilogram, and second respectively. You can see that the names CGS, FPS, and MKS have been derived from the names of units, the system of units which is at present internationally accepted for measurement is the Système International d'Unités. This is French for International System of Units, abbreviated as SI. The SI, with standard scheme of symbols, units, and abbreviations, was developed and recommended by General Conference on Weights and Measures in 1971 for international usage in scientific, technical, industrial, and commercial work. Because SI units use decimal system, conversion within the system are quite simple and convenient. In SI, the 7 base units are defined in the following table. Our first base quantity is length. The name of its SI unit is meter. The symbol is small m, and we define it as the meter is the length of the path traveled by light in vacuum during a time interval of 1 by 299,792,458 of a second. The second base quantity is mass. The name of its SI unit is kilogram. It's symbolized by small kg, and it is defined as the kilogram is equal to the mass of the international prototype of the kilogram, which is a platinum indium alloy cylinder kept at International Bureau of Weights and Measures at Sèvres near Paris, France. The next base quantity is time. The name of its SI unit is second. Its symbol is small s, and it is defined as the second is the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of the cesium-133 atom. Our next base quantity is electric current. The name of its SI unit is ampere, and it's denoted by capital A. The ampere is that constant current which, if maintained in current to straight parallel conductors of infinite length of negligible circular cross section and placed 1 meter apart in vacuum, would produce between these conductors a force equal to 2 into 10 raised to the power minus 7 Newton per meter of length. The next base quantity is thermodynamic temperature. The name of its SI unit is Kelvin. The symbol is capital K. It is defined as the Kelvin is the fraction 1 by 273.16 of the thermodynamic temperature of the triple point of water. The next base quantity is amount of substance. The name of its SI unit is mole. It is symbolized by small mol. It is defined as the mole is the amount of substance in a system which contains substance as many elementary entities as there are atoms in 0.012 kilogram of carbon-12. The next base quantity is luminous intensity. Name of its unit is candela. It is denoted by symbol small cd, and it's defined as the candela is the luminous intensity in a given intensity direction of a source that emits monochromatic radiation of frequency 540 into 10 raised to the power 12 Hz, and that has a radiant intensity in that direction of 1 by 683 watt per steradian. In this, the base units for length, mass, and time in these systems were as follows. In CGS system, they were centimeter, gram, and second respectively. In FPS system, they were foot, pound, and second respectively. In MKS system, they were meter, kilogram, and second respectively. In this table, you can see some units which have been retained for general use. Supplementary physical quantities. Plane angle d theta as the ratio of length of arc ds to the radius r. Solid angle d omega as the ratio of the intercepted area dA of the spherical surface described about the apex O as the center to the square of its radius r. The unit for plane angle is radian with the symbol rad, and the unit for the solid angle is steradian with the symbol SR. Radian is defined as the angle subtended at center when length of arc is equal to the radius of circle. A steradian is defined as the solid angle subtended at the center of a sphere of radius r by a portion of the surface of the sphere whose area A equals r square.